Please click on the subscribe button and press the bell icon for watching more update videos. Thank you. Hello everyone, once again, and welcome to my channel. Please don't forget to subscribe to my channel and press the bell icon for watching more update videos. Hello guys, once again. So today I'm going to calculate a simply supported beam for beginners. As one of my YouTube family recommended me to make a video on a simply supported beam for beginners. And also I will teach you guys how to draw the shear force diagram and bending moment diagram of the beam. So I will go step by step. So at point A, we have a pin. So we know the pin has two reactions. So VA, and we have a horizontal reaction which is HA. At point B, we have a roller, so it has only one reaction, which is vertical reaction, so which is VB. So first step, always take summation of Fx, which is equal 0. So I have only HA. Do I have any forces acting towards horizontal direction? No. So now our HA will be equal 0. So next step, take summation of Fy, which is equal 0. So I have VA plus VB, because acting at the same direction, minus 10 kilonewton minus another 10 kilonewton, with the distance are 2 meter, 2 meter and 3 meter. Which is equal to 0. So now the VA plus VB, so put this to 10 to another side, will become positive. So plus 10 kilonewton plus 10 kilonewton. So my VA plus VB will be equal to 20 kilonewton. Now the next step, take summation of moment. You can take moment at point A or at point B. So I'll take a moment at point A first. So summation of moment at point A, which is equal 0. So here's my moment now. So I have VB is acting anti-clockwise. So I'm assuming anti-clockwise is a positive. So VB, what is the total distance? 2 plus 2, 4. 4 plus 3 is equal 7 times 7. So my VB is acting anti-clockwise, and I have two pine loads is acting clockwise. So which means my VB is acting opposite of the pine loads. So therefore my VB will be equal to, I have 10 kilonewton, where the distance is 2 meter, plus I have another 10 kilonewton times the distance is 4 meter now. So I have 7 VB is equal 10 times 2 is 20 plus 4 times 10 is 40. So 7 VB will be equal to 60. So both sides divided by 7 to find the value of our VB. So 60 divided by 7, which is 8.6 kilonewton. And the value of my VA will be equal to, so as I mentioned earlier, my VA plus VB is equal to 20 kilonewton. So what I will do now, so 20 minus 8.6 is equal to 11.4 kilonewton. So that's the reaction of my VA and VB. So the next step, I will teach you guys that how to draw the shear force diagram and bending moment diagram of the beam. I will go step by step. So now I will draw my shear force diagram first. So shear force diagram. Let me draw the straight line first. So look, at point A, we have 11.4 kilonewton is acting upward, yeah? So which means we have to go up to 11.4 kilonewton, which is 11.4 kilonewton. Look, from point A to up to 2 meter, we don't have any force acting. So, and also we don't have a no UDL, therefore it goes straight like that because we don't have any force to pull it down. So it goes straight like that. But we have 10 kilonewton is going downward. So which means now, so I have positive 10, positive 11.4. So 11.4 minus 10 kilonewton, which is 1.4 kilonewton left. So I will go down up to 1.4 kilonewton up to here. So this one here 1.4 kilonewton. And also from this point load to the another point load, we don't have any other forces. So therefore it goes again straight up to this point load, up to 2 meter. It goes like that, straight. We have a what? We have a 1.4 here, yeah? So now what we do now? So 1.4 minus 10, which is 8.6 kilonewton. So we have 8.6 going downward, like that. 8.6 kilonewton. And from 8.6 up to point B, we don't have any forces to pull it up or to pull it down. So therefore we go straight like that. And at the point B, we have 8.6 kilonewton goes up again. So if 8.6 minus 8.6, it will be equal 0. So that's our shear force diagram. And the next step, to draw the bending moment diagram, so we have to know, for example, this our straight line. If our line of intercept touch the straight line, then you have to take cut. For example, look, in this example, it only touched once. So therefore, we take only one cut. So now, I'll take my first cut from 3 meter. So I'll take the first cut from 3 meter. I'll take like that. I have vertical reaction, which is 8.6 meter. I have the distance 3 meter, and I don't have any other forces. So the moment, I'm calling it as M1. So my M1 will be equal to 8.6 because my moment is here. 8.6 times the distance, which is 3 meter. So M1 will be equal to 8.6 times 3, which is equal to 25.8 kilonewton. So I have found the value of my moment. So now I'm going to draw the bending moment diagram. So bending moment diagram. So I have found out the value of my bending moment, which was 25.8 kilonewton meter, yeah? So it was from 3 meters. So it's positive, therefore it goes down here. So 25.8 kilonewton meter. if we have a UDL, if you have a UDL beam, our bending moment will be curved. It will go curved like that. But our beam, it doesn't have a UDL, therefore it goes straight like that. Just take a ruler and draw it. So just straight. And also, when you have simply supported beam, so you have to know that your starting point and end point has to be at 0. So I will do another example on UDL beam, and then I will draw the shear force diagram and the bending moment diagram of the beam, and then I will teach you guys that how to draw it. So in the second example, I'm going to solve a simply supported beam with UDL and point loads. So point A and point B. So I know pen has two reactions, so VA and HA, horizontal reaction and vertical reaction. Roller has only one reaction, which is a VB, vertical reaction. So first step, summation of Fx, which is equal 0. So I have horizontal HA. I don't have any forces acting towards horizontal direction, so therefore our HA will be equal 0. Second step is Fy is equal summation of Fy equals 0. So I have VA plus VB, that will be equal to, because VA plus VB is opposite, 10 kilonewton, this 10 kilonewton plus UDL. So 10 plus 10 plus 5 times 7, the total distance is 7. So VA plus VB, and that will be equal to, so 5 times 7 is 35 plus 20, which will be equal to 55 kilonewton. So now I will take summation of moment at point A. I'm assuming that anti-clockwise are positive. So VB times the total distance is 7 meter is equal, because the rest of the point loads acting clockwise, only VB is acting anti-clockwise. So therefore my VB will be equal to, so 10 kilonewton times the distance, which is 2 meter, plus this 10 kilonewton times the distance is 5 meter, 3 plus 2 is 5, plus I have a UDL, 5 times the total distance is 7 meter times 3.5, because acting at the middle, that's why 7 divided by 2. So 7 VB will be equal to 20 plus 50 plus 5 times 7 times 3.5, and that will equal to 122.5. So my VB will be equal to 20 plus 50 plus 122.5 divided by 7, and that will be equal to 27.5 kilonewton. And my VA will be equal to, so 55 minus 27.5, and that will be equal to 27.5 kilonewton as well. So that's the value of my VA and VB. So now I will draw the shear force diagram and bending moment diagram of this UDL beam. So now I'm going to draw my shear force diagram first. So at point A, I have 27.5 kilonewton, which is going upward. So my shear force will go up to 27.5 kilonewton. That's 27.5 kilonewton. And I have a UDL for 2 meter. So now, because the UDL is pulling it downward, so I have positive 27.5. So I have 5 times 2 is 10, yeah? So 27.5 minus 10, I have 17.5, which is going downward up to here. So 17 point up and goes like that. That will be 17.5 kilonewton. And I have another 10 kilonewton, which is acting downward again. So it goes up to here. So 17.5 minus 10 is positive 7.5 kilonewton. So here will be 7.5 kilonewton. So I have a 3 meter UDL. So now 5 times 3, that will be 15. 15 minus 7.5, and that will be equal to minus 7.5. So it goes like that up to 7.5. And I have, so here 7.5 kilonewton. And I have another 10 kilonewton, which is going downward again. So I have minus 7.5 minus 10, which is minus 17.5 kilonewton. So you don't need to put the value because it's downward is always negative. So I have another 2 meter UDL. So 17, so minus 17.5 minus 10, that will be equal to minus 27.5. So it goes like that again. So 27.5 kilonewton. So it's minus. And here we have positive 27.5 again at point B. It goes up. So minus 27.5 plus 27.5, that will be equal to 0. So look, the shear force diagram at point A and point B, it has to be 0 always. So now I will draw my bending moment diagram. It was my shear force diagram. Now I will draw my bending moment diagram. So I'll draw my bending moment diagram now. Before I draw my bending moment, I have to know that what is the distance from here to here, because I will take cut from this point, yeah. So I know the distance from here to here is 2 meter, yeah, isn't it? Yeah, 2 meter. So what is that distance now? So this distance, what we do, the distance is the reaction divided by the UDL. You'll get the distance. So my reaction is 7.5, this one, divided by 5, and that will be equal to 1.5 meter. So now the total distance is 3 meter now. So I'll take cut from 3 meter. So my total distance is 3 meter now. I have a UDL, which is 5 kilonewton per meter. And I have 10 kilonewton, which is going downward again. So we know the total distance is 3 meter, yeah? But from 10 kilonewton to here, the distance is 1.3 meter. 1.5 meter, sorry. Distance 3.5 meter. So 1.5 meter, this distance is equal 2 meter. So total distance is 3.5 meter now. I'll take a moment, yeah? I'm calling it as M1. So my M1, so my moment is here now, yeah? M1 plus, I have a, and also I have a reaction which is 27.5 kilonewton. So I have M1 plus, I have 5, the UDL, times the total distance is 3.5 times, because the UDL is always acting at the middle, so 3.5 divided by 2 is 1.75 plus 10 kilonewton times the distance is 1.5. That will be equal to, because look, my moment is acting anti-clockwise, this 5 kilonewton is acting anti-clockwise as well, 10 kilonewton is acting anti-clockwise as well. So therefore, my M1 plus 10 kilonewton plus my UDL, and that will be equal to, because this reaction is acting clockwise, opposite my moment, so 27.5 times the total distance is 3.5 meter. So my M1 plus 5 times 3.5 times 1.75, and that will be equal to 30.625 plus 10 times 1.5, it's 15. It will be equal to 27.5 times 3.5, and that will be equal to 96.25. So my M1 will be equal to 96.25 minus 30.625 minus 15. It will be equal to 50.625 kilonewton meter. And that's my moment. So my moment was at point from 3.5 meter. So here was my moment, yeah? I'll do go like that. So my moment is positive, that's why it's going down. So here, which is 50.625 kilonewton meter. So look now, so we have a UDL. For example, just assume this is our beam, yeah? When you put the UDL, look at bends, isn't it? Yeah? So therefore, our moment will be bent like that, not straight like my previous example. It bends like that. And thank you guys for supporting me and watching my videos. If you have any question regarding this example, please comment below and I'll reply to your message as soon as possible. Thank you very much.